Today I'm going to talk about productive struggle. Specifically, I'm going to talk about 5 empirical articles I've read recently that relate to productive struggle. Now, prior literature has already established the importance of productive struggle. If we want kids to have meaningful learning, well, then they need to productively struggle with the mathematics. These are some questions about productive struggle that were addressed in the studies I read. Why do some tasks elicit productive struggle when others do not? What types of problems should students be struggling with? What pitfalls do teachers encounter when trying to promote productive struggle? How long should we delay introducing structure into instruction? How does productive struggle affect student agency? So first, why do some tasks elicit productive struggle when others do not? Well, this first study I read talks about the basic idea is that an impasse motivates a student to take an active role in constructing a better understanding of the principle. So if we want students to engage productively with the mathematics, we need to perplex them first. They need to come to that cognitive impasse. So again, if we want meaningful learning, we need kids to engage in productive struggle. If we want them to engage in productive struggle, we need to initiate a cognitive impasse in our students, which is of course the same thing that both Dewey and Piaget said a long time ago. What types of problems should students be struggling with? Well, certainly students can struggle with any math problem. This study looked specifically at the differences between students struggling with traditional math problems versus more complex word problems. And this is what the study found. Students who experienced problem-based instruction more often were able to integrate newly acquired concepts with existing knowledge structures that had been activated. In more everyday language, they demonstrated understanding. Put in simpler terms, the answer to what's good about problem-based learning is that it promotes sense-making, which is of course the first standard for mathematical practice in the Common Core. Now interestingly, when we looked at traditional problems versus more complex problems, students did equally well when they were prompted with recall questions on the post-test. But when they were asked to integrate the concepts into a novel situation or into a more higher order analytical situation, students who were taught through problem-based strategies did much better than those taught on traditional problems. Now, what pitfalls do teachers encounter when trying to promote productive struggle? Here you can see the number one problem that teachers encounter is challenges becoming non-problems. And also you can probably see very low on the list is this idea of classroom management. But I want to talk a little bit more about what does it mean challenges become non-problems. What it means is that the problematic aspects of the task somehow became routinized, either through students pressing the teacher to reduce task ambiguity and complexity by specifying explicit procedures or steps to perform, or by teachers taking over the challenging aspects of the task and either performing them for the students or telling them how to do it. In many instances, teachers appeared to find it difficult to stand by and watch students struggle, and they would step in prematurely to relieve them of their uncertainty and sometimes emotional distress and not being able to make headway. All too often, however, teachers would do too much for the students, taking away students' opportunities to discover and make progress on their own. Now, who is this kind of teaching for? Conventional wisdom suggests that using complex thinking tasks with students in urban schools, where behavior problems and inadequate preparation and basic skills are presumed to be prevalent features of the student body, is a prescription for out-of-control classrooms. On the contrary, our findings suggest that students attending urban schools in disadvantaged neighborhoods can work on high-level tasks without becoming disruptive and non-productive. How long should teachers delay introducing structure into instruction? Well, this study looked at a control group who was taught the traditional lecture practice style, where the teacher would lecture, the kids would practice in class and homework, and the teacher would give them feedback on how well they were doing, versus the experimental group called the productive failure class, where you can see students spent 6 periods struggling with the mathematics. On the 7th day, the teacher consolidated the class's work and shared the key mathematical ideas and structures with the class. Notwithstanding, it was remarkable that productive failure students who were not given any homework or practice assignments during instruction still managed to outperform lecture practice students on the well-structured items, the type of items that the lecture practice students solved and received regular practice and feedback on during instruction. Thus, students from the productive failure class outperform those from the lecture practice class on both the well-structured items as well as the higher order analysis and application items on post-test 1. Why did this work? Well, the process of generating a diverse set of structures while exploring the problem and solution spaces may have engendered sufficient knowledge differentiation, even though it did not result in a successful solution. Such knowledge differentiation was critical for learning because it prepares students to better discern and understand those very concepts, representation, and methods when presented in a well-assembled, structured form during the consolidated lecture. Discernibility, in turn, may have resulted in better knowledge assembly. And therefore, compared to the lecture practice condition, the delay of structure in the productive failure condition may result in students attempting to assemble key ideas and concepts underlying rate and speed, as well as generate their own structures, representations, and methods for solving the complex problems. Interestingly, in this study, on the post-test, they asked students to solve some rate problems they weren't even exposed to during their 7-day unit on rate, and students in the lecture practice condition weren't able to solve this that they weren't exposed to, but students in the productive failure class actually were successful on it, which was pretty cool. How does productive struggle affect student agency? This research quotes prior literature in talking about, because of their stable nature, research has focused primarily on the role of beliefs and attitudes on the learning of mathematics. The results indicate that beliefs and the resulting attitudes are strongly linked to school achievement. They are the gatekeepers to learning. Before a student can even begin to engage in mathematical content, they have to first decide that they are both capable of learning the presented material and willing to do so. So when these pre-service teachers productively struggled with the mathematics, they had several aha moments, and you can see that they felt, obviously, they were pleasurable experiences, and more importantly, they changed their beliefs about themselves and their agency in mathematics. So for leaders, why is this research important? Well, as leaders, we need to have a framework for how students learn math so that we can support our teachers in helping students learn math. And here's what that framework might look like from these 5 studies. So originally, we knew that productive struggle was needed for students to have meaningful learning. Well, now we know that in order to get that productive struggle, kids need to be confronted with a cognitive impasse. And that the productive struggle should be on rich, complex problems, not the traditional problems that we're used to. Now, one way for a productive struggle environment to go wrong is for teachers to over-scaffold to a non-problem. We need to make sure teachers aren't turning these complex problems into non-problems by helping too much, where a once rich problem is now merely a set of steps for students to follow. Now, what teachers should be doing is delaying giving those mathematical structures. Have students create several of their own structures before exposing them to the formal mathematics. And finally, we can't forget about student agency and its bidirectional nature with productive struggle, meaning that students who have high sense of mathematical agency are going to productively struggle with mathematical tasks more, and kids who productively struggle with mathematical tasks more are going to develop greater student agency. We as leaders need to support teachers who are deviating from the curriculum map in order to build student agency. Thanks for listening.